It's time to scaffold a project with a package called Create Vue. It's the official tool for building, compiling, and managing Vue applications. It's completely optional, but I absolutely recommend it if you plan on building complex Vue apps. Before running this package, let's talk about it briefly. The Create Vue package is a tool manager. Its purpose is to help you organize your files, pre-configure tools, and let you start building your application right away. The code base of an application can be broken into two parts. There's the application code and code from external libraries. Code from external libraries can be considered code from libraries like Vue or Axios. It's code we didn't write, but are using in our application. Application code is the code we've written to get a functioning application. Splitting your code base into different files is ideal for development. It makes things easier to manage and track. It allows for flexibility when you need to update files. The problem with this approach is the amount of files that can be present in an application. They can be scattered across several directories. This introduces the necessity for tools like Vite, PostCSS, and Sass. Tools can help us manage an application. Best of all, we can bundle files into as few files as possible. A new problem is introduced. These tools are independent from each other with separate configuration settings. On top of developing our application, we would have to take the time to manage a tool set. They need to be configured to work alongside each other. The more tools we introduce, the more complex configuration can get. It's a lot of work just to get an app up and running. This is where the Create Vue package comes into play. This package will help you with setting up a Vue project with Vite and other tools. Sounds redundant, but it makes the process massively simpler. It'll even provide you with a basic setup if you wish. Alternatively, you can create a custom setup for future projects. By using this package, our project will be ready for development and production. If you watched the previous section, you learned how exhausting it can be to configure tools. There's a lot that needs to be done before diving into app development. It's not a pleasant experience to go through every time you want to start a new project. Vue will expedite this process by asking you a few questions about your project. Based on your answers, it'll configure the tools necessary for running a Vue project. This tool will allow you to jump straight into your project. You also have the option of adding additional features you may need as your development workflow progresses. What took an hour to set up in the previous section will only take a minute with the Create Vue package. In the resource section of this lecture, I provide a link to the official Create Vue repository. Here you'll find more information about this tool and what you can do with it. At the bottom, we're given some commands to get us started with this tool. Let's try running the CLI together. Switch over to your command line. Inside the command line, input the following command: npm init vue at latest. After the @ character, we can input the version of Vue. For example, we may want to create a project with version 2. We can input this version like so. If you're not interested in specifying the version, you can type latest for the most recent version of Vue. Before you run any commands, I recommend you place yourself in a directory exclusively for development projects. Vue will need some room to build the project when we run the command. Let's run this command. It can be dangerous to run packages. As an extra precaution, npm will ask us to verify our actions. In this case, I think it's safe to run this package. Afterward, we need to provide a project name. The name of our project will be called Components. The topic we'll be discussing in this section will be about components. The name will reflect that. Feel free to use a different name if you'd like. Up next, we're going to be asked a series of questions for specific packages. In the future, we are going to integrate several packages. For now, let's select No for everything. After selecting this option, Vue will begin creating, preparing, and configuring your project. This may take a while for some of you, just be patient. After some time has passed, Vue will tell us the project has been successfully created. From here, it'll tell us to execute a couple of commands to start the server. Let's move into the directory first. Before we start the server, let's briefly look at the files and directories. Some of these files should be familiar to you. If you know what these files do, then that's great. If not, that's fine as well. We'll review them shortly. We were able to get a starter project with a single command. It created a list of modules, configured them, and generated files for getting started. It saved us time from having to do this ourselves. From the beginning, you can see the benefits of using this package. We're free to edit any of these files. We can make changes to the current configuration at any point. We're not forced to use the default configuration settings. We'll dig deeper later, but let's try running on the server. Under the hood, the project has been configured with Vite. We have access to the same features as the previous project. This includes the server. We didn't use a server for most of this course. This is because we were dealing with 1 or 2 files. We weren't making external requests. We're going to be discussing more advanced topics. A server will be necessary because browsers impose limitations on files opened directly in the browser. To remove any limitations, we'll need to deliver the files via a server. Fortunately, we don't have to worry about the code that makes the server function. It works completely out of the box. This allows us to focus solely on the project itself. Switch over to the command line. First, we must install the packages from the package file. Packages are not installed for us. They must be manually installed. In the command line, run the npm install command. Next, type the following command: npm run dev. This is a command you can find inside the package file. This command will start a server. The server will bundle our project and serve the bundle for us. We can preview our project with this command. After a few moments, Vue will tell us that the project was successfully compiled. This is something important I want to highlight. If you can recall, there are 2 versions of Vue, one with the compiler and another without it. The one we're using in our project is the one without the compiler. Vite has been configured to compile the template during the build process. The template will be transformed into a render function. The final bundle outputted by Vite will not need to be compiled on the client. We can continue writing HTML and not worry about having to code objects for the virtual DOM. Below this log will be presented links to view our application. We can click on them to open a new tab in the browser. You will see something similar to what I see. There are links we can click on to learn more about the tools that were installed. One of the main selling points of Vue is its simplicity. However, for quite some time, in order to create complex projects, you had to learn and configure various tools. Vue was designed to allow us to focus on our project. There may be times when you'll want to configure Vite differently, but we'll take a look at that later. For now, the default configuration works fine. Therefore, we'll be jumping into the project very soon. In the next lecture, we'll go a little deeper into the files scaffolded by the Create Vue package. In this lecture, we're going to briefly talk about servers. In the previous lecture, we ran a command that started a server for us. We were able to view our application in the browser by visiting a special URL. Let's examine the URL closely. Our browser is pointing to a URL called localhost followed by some random numbers. What is localhost? What do these numbers represent? Our application is being served by a server. Let's explore what that means. A server is a machine similar to our personal computers. One of the major differences between a server and our computers is that there is no GUI. We can't click on icons, buttons, or view graphics in general on servers. So what's the point of having a server? A server can have software installed on them for handling network requests. The job of a server is to listen for incoming requests. Whenever we type a URL in the address bar of a browser, the browser will initiate a request to a server. The server is responsible for responding with some data. This can be a file like an HTML, image, CSS, or JavaScript file. The job of a server is to hold a copy of our application. The main benefit is not having to maintain the server on our machines. We don't have to purchase the hardware, set up, or maintain a server. There are services available that specialize in hosting applications on servers. Up until now, our application has been working without the need for a server. We've been opening files directly in the browser. We're going to be using some advanced features of the browser. Browsers limit features if we open files directly in the browser. This includes HTML files. Here's where our problem begins. We need a server to host our application. Luckily, we won't need to write a server. Vite provides a server out of the box. It allows for developers to continue writing Vue applications without having to worry about running a server. In the address bar, our app is delivered by a URL called localhost. Localhost is a special URL we can type in the address bar. If we type localhost, the browser treats the request differently. Instead of sending the request to a server located somewhere in the world, the request will be sent to our computer. This allows our computers to handle the request. Vite will run a server on our computers that can handle the request if we type in localhost. The server will respond with the HTML, CSS, and JavaScript files we have in our project. We don't need to write a single line of code to get this functionality working. That's great because it allows us to focus on our app. The CLI adds additional features to our project that make the development experience easier. The server will watch for file changes in our project. If a file is updated, the server will refresh the browser to show the latest changes. That saves us time from having to refresh the browser ourselves. There's a whole lot of other things the CLI can do for us which we'll learn about as the course progresses. There's one last question. What do the numbers represent? This part of the URL represents the port number. You can think of ports as doors to a house. A house can have numerous entrances. One door leads to the kitchen, another leads to the bathroom, so on and so forth. Similarly, servers have ports for accessing different parts of a server. The browser needs to know which door on the server leads to the application. Multiple applications can exist on a server. We need to assign a port for our app. By default, the CLI will assign the app to a port for us. The port can be specified in the URL by adding a colon after the domain. This character is followed by the port number. Normally, we would never have to add the port number to the URL. For example, let's change the URL to google.com. The port number is not necessary for this URL. The reason we don't need to add a port number is because most browsers will default to port 80. Most applications are configured to be delivered over port 80 on the server. Port 80 is the recommended port when shipping an app to production. So why does CLI use a different port? Only one application can be assigned to a port. You can't have multiple apps using the same port. On most personal computers, it's possible that port 80 may have been taken. Luckily, computers have thousands of unused ports. The CLI will search for an unused port. It'll reserve the port for our application. This way, we can view the app on our machines locally. That wraps it up for now. We can tell the browser to access our server by typing in localhost in the URL. We don't have to worry about the restrictions imposed by the browser because we have a server to deliver our app. In the future, we'll look at how we can upload the app to a server for production. For now, we'll be working locally. In this lecture, we're going to review the files generated by the Create Vue package. We'll start with the root files. Then, we'll move on to the directories. The very first file is the gitignore file. This file is for those who plan on using Git or GitHub. It'll instruct Git what files should be ignored when you push files into the repository. You don't want to upload every file in your project. The CLI has taken the opportunity to list files you shouldn't upload, files that shouldn't be shared with others. If you plan on using Git for this course, then this file is beneficial to keep around. For this project, we won't be using Git. Feel free to delete or ignore this file. The following file is called index.html. If you were to look inside this file, it'll be the same HTML file from the vanilla JavaScript project with minor modifications. Overall, the index file serves as the entry point to our application. It's importing the script file from a directory called source. We'll look at this file in a moment. Up next, we have the package file. There are some interesting things going on in this file. Firstly, the dependencies object contains the Vue package. Previously, we installed Vue through a CDN. This time, we're going to work with a local copy. In the development dependencies object, we have an additional package called plugin Vue for Vite. Naturally, Vue does not work with Vite. Vite does not assume which front-end framework we're using. For this reason, we are installing an additional plugin for integrating Vue with Vite. Moving forward, we have the README file. The contents of the README file has information about how to run the project, basic information to help you get up and running. There's even a link on how you can configure the project created for you. The topics covered in the documentation are things we'll go over as the course progresses. Lastly, we have the vite.config.js file. There are two noteworthy things about this file. Firstly, Vue is configured with the project by importing the Vue function. This function is called directly from the plugins array. Luckily, we don't need to dive into the inner mechanics of this plugin. All we need to know is that the plugin will help Vue understand Vue files. If we were to view the files inside the source directory, we'll find some files with the Vue extension. The Vue plugin will help Vite process these files. We'll explore what Vue files are later in this course. You may have noticed it already, but a configuration file for PostCSS is not present. It's one of the tools we discussed earlier. Despite that, the Vue plugin will configure PostCSS for us. It may not look like it, but our project CSS will be processed by PostCSS. Regardless, you may want to configure PostCSS. We are allowed to configure PostCSS by adding the PostCSS property to the package file. Vue will prioritize the settings in the package file over its own. Feel free to add it. For this project, the default configuration will work fine. The second noteworthy thing in this file is the resolve.alias property. You can think of an alias as a shortcut to a directory. Throughout this course, we're going to be importing dozens of files in nested directories. It can be tedious to write paths to files. To keep things simple, we can create an alias to a specific directory. In this configuration file, we're provided an alias called @. This alias points to the source directory. Here's an example. Let's say we had a file called example.js. There are two options for importing this file. Firstly, we can type the path to the file. Alternatively, we can replace the source directory with the @ character. Vite will handle replacing this character with the appropriate path. Keep in mind, the alias is only available with Vite. We can't use the alias outside of it. Using the alias is completely optional. That concludes the files in the root directory of our project. Up next, we have three directories. The Node Modules directory will contain the modules installed for this project. The public directory contains your static assets like images and HTML files. By default, the project will provide us with a favicon file. There's not much going on in this directory. Next up is the source directory, which is probably the most important directory. It will contain most of your application's logic, templates, state management, etc. We will be spending a majority of our time in this directory. Let's start with the main.js file. Inside this file, we're importing two things: the createApp function from the Vue package and an object called app. The createApp function is what will create the application as we've learned in previous sections. The Vue module can be found inside the Node Modules directory. The project is set up to automatically look for the Vue module. You don't have to worry about the path. The app module is a bit peculiar. We're not loading a plain JavaScript file. We're loading a Vue file. Vue files are considered components. They all end with the Vue extension. Upon inspecting the file, you will find a lot is going on. Before I break down what's going on, you may not have syntax highlighting for this file. If you're using Visual Studio Code, you can install a plugin called Volar. This plugin will enable syntax highlighting for Vue files. I recommend installing it if you have Visual Studio Code. If you're using a different editor, search for a plugin that will enable syntax highlighting. Let's break down what's inside a Vue file. Files that end with the Vue extension are called single file components. Single file components are made up of 3 blocks. There's the HTML, JavaScript, and CSS. The HTML is placed inside the template block, the JavaScript is placed inside the script block, and the CSS is placed inside the style block. All 3 blocks are compiled into a JavaScript object. This way, when we're importing the object in other files, it'll be usable because it's an object. The object exported will contain all 3 blocks. Let's examine what a single file component looks like after it's been compiled. Inside the command line, we'll run the command npm run dev and open the page in the browser. Next, I'm going to switch back to the app component and make a small change. I don't expect you to follow along, just watch. After making this change, I'll switch back to my browser with the developer tools opened. Inside the network panel, there will be a request that we can click on. This request will contain the changes made to the file. I'm going to copy everything inside this request and paste it into a random file. Alright, as you can see, I've stripped down what was returned by the request. I've removed most of the references to Vite. They're not needed to understand this example. This is the only part that matters to us. I know I went through a lot to get to this point, but this is the main thing I want you to focus on. Don't worry about the other stuff. This bit of code is what the template inside the app file gets compiled to. It gets turned into a render function. Inside the render function, there's a lot of confusing things going on. However, understand one thing. The value returned by the render function must be an object that represents the elements we want to render on the document. This function has been produced by Vite and the Vue plugin. The purpose of writing single file components is to make this process easier. If you had to pick between writing out your application between a render function and the single file component, then you may lean towards the single file. That's the basics of it and all you really need to know. We're going to continue using single file components as it makes our code readable and manageable. Let's go back to reviewing the files. Back inside the main script file, we're using the createApp function to initialize the app. We're passing in the app component to the createApp function. Vue will run the render function because that's what the single component file will be compiled to. The last thing going on here is the Vue application being mounted. The mount method is called to start this process. This wouldn't work without Vite. Thanks to Vite, creating components has been simplified. This has been a basic review of everything. Of course, there's way more to it, but we'll dive into other topics as the course progresses. It's time to start writing some code. When we installed the project, we were given a few starter files inside the source directory. It provides a basic example on how you would create components and structure them. That was nice and all, but I want to start from scratch. We'll clean up the project so that we can focus on the basics. We're going to delete the components and assets directories. Neither are necessary. Then inside the app component file, we're going to remove the style block. Adding CSS to a component is completely optional. If you decide not to have stylings for your component, then Vue will not throw an error. We're also going to reduce the code inside the script and template blocks. On the script block, remove the setup attribute. This attribute is a shorthand syntax for the composition API, which we won't be using in this section. Unless I state otherwise, this attribute should always be removed from the script block. The bare minimum requirements for a single component file to be valid is the template block. The template block must contain at least one root element. We're allowed to have multiple root elements in an application. Inside the template, we're going to add a simple greeting in the form of a paragraph. Let's make the greeting more dynamic. Inside the script block, we're going to export an object. The object we're exporting will be used for the component settings. This is where you should add your data, methods, computed properties, and watchers. Everything's the same as before. Before we jump into adding the data, I want to assign this component a name. We'll add a property called name. The name property isn't required, but it can be useful for debugging. The Vue developer tools will use this property for the name of the component. Sometimes Vue will display components as anonymous when it doesn't know what name to give it. By assigning a name to your components, it'll become easier to identify them in the developer tools. We'll set the name option to app. You can name your components whatever you want. Generally, you should keep it to alphanumeric characters and hyphens. Next, let's set up the data function. Inside this object, we'll add the property message with a value of hello world. Next, we'll replace the static text in the template with the expression message. Let's give things a test. Inside the command line, run the command npm run dev. You shouldn't receive any errors thus far. We'll preview the app in the browser. We'll see the message get outputted in the browser. This confirms the component is working. Almost everything we've learned so far still applies to components. The main difference is that we have a better separation of logic. It's much easier to work with components when the template has syntax highlighting. If we were to open the Vue developer tools, we would find the component with the name we gave it inside the name property. Once again, this is useful for debugging. The dev tools tend to give some components the name anonymous. Assigning a name to your component will stop that from happening. The developer tools will capitalize the name for you if you decide to keep it lowercase. That's the basics of creating a component with single file components. We'll continue exploring what else we can do with component files in the next lecture. In this lecture, we're going to move on to the next step, which is creating child components. We already saw how to do this previously, but there are a couple of additional things I want to show you. What we'll do is put the greeting into its own component. It shouldn't be difficult to pull off. In fact, why don't you give it a try? Try creating a greeting component with a dynamic message. Then try loading it inside the app component. Pause the video and good luck. Welcome back. If you were able to take on the challenge, then congrats. If not, that's fine as well. We'll do it together. The first step is to create the file. It's always good practice to keep your components organized. We'll place our child components inside a separate directory. Inside the source directory, create a folder called Components. Inside this newly created directory, create a file called greeting.vue. It's common practice to use camel casing for your component names. It's not required, but recommended. Inside this file, we'll want to add the template and script blocks. We can type those blocks out, but there's an easier way to create them. Switch over to the Extensions tab. There's an extension created by the community of Vue for creating components. Search for an extension called Vue vs Code Snippets by a user called Sarah Drasner. Install this extension on your editor. It's going to be helpful. After installing it, switch back to the greeting component. If I start typing Vue, Then Visual Studio Code will provide me with a drop-down of snippets I can add to the file. This is possible thanks to the Vtur extension we installed. If you're not using either of those, then you'll need to type out the blocks manually. You can select any of these options and Visual Studio Code will pre-fill your file with the snippet you selected. I typically like to go with the very first one. After selecting it, all 3 blocks are inserted for us. We're going to remove the style block because we won't be using it. In addition, the setup attribute can be removed. For the rest of this course, I'm going to use this shortcut whenever we create single file components. Unless I say otherwise, I will also remove the style block whenever I do so. It's not something we will use often. Let's continue working on the component. For the template, we're going to cut and paste the paragraph element from the app component to the greeting component like so. Next, we're going to copy the contents of the script block from the app component. We'll paste it into the greeting component. We're going to need to make one change to the greeting component. We'll change the name to greeting. We're finished with prepping the greeting component. The next step is to load this component inside the app component. Switching back to the app component, we don't need the data property anymore. It has been moved into its own component. Therefore, we'll remove the data function. The next step is to load the component. There are 2 ways to load a component. You can do it on a global level and on a local level. We learned how to do it on the global level previously. To register a component globally, we need to use the component method. Let's use this method inside the main.js file. This is the file where we are initializing the Vue application. We'll need to make some adjustments to the way we initialize the application. Currently, we're chaining the mount method. However, we need to register the component before we mount the application. We'll separate this by assigning the returned value from the function to a variable called VM. Afterward, we'll chain the mount method to the variable. In between these 2 lines, we'll register the component. Components must be registered after a Vue instance. We'll call the component method on the VM variable. At the top, we'll import the greeting component. There are 2 things I want to quickly note about this import statement. We're including the Vue extension in the import statement. We need to make sure Webpack understands we're importing a single file component. Be sure to include this extension in the import statement. Secondly, the name of the import is called greeting. This is the same name in the component's name property. This is common practice so that it's easier to find the component, but you can call it whatever you want. You don't have to use the name you assigned in the name property or the file name. From here, we can pass in the name of the component, which will be greeting, and then the component itself. We don't have to worry about passing this in as an object. Webpack will compile it into an object. Vue will understand what we're trying to do. This is how you register a component globally. Global components can be used anywhere in Vue. This includes children components. However, this usually isn't recommended. Global components tend to make optimization harder for module bundlers like Webpack. Our application will still work, but it's best practice to register a component locally. That way you don't end up loading every single component in your application, even the ones that aren't active. Let's learn how to do that. We're going to comment out both lines. Local components can only be used in the component it was registered in. The app component is the only component we have that will be using the greeting component. To register a component locally, we can add a property to the configuration called components. The value for this property is an object. The object will contain a list of components that can be used inside this component. Like last time, we'll need to import the greeting component. Next, we'll add a new property to the object where the key name will be the name of the component and the value will be the component itself. The key name will be greeting. The value will be the greeting component. Thanks to ES 2015, we can shorten this to greeting. It'll automatically be interpreted to what we previously had. This is how you register a component locally. The components property allows you to specify what components the current component can use. The last step is to use the local component. In the app components template, we'll add a pair of tags with the name greeting. Let's refresh the page in the browser. We will still see the greeting in the document. Using the Vue Dev tools, we'll find the greeting component nested inside the app component. This confirms that our app is using the greeting component we registered. Checking the dev tools is a great way to verify if a component is being registered successfully. Vue gives us the flexibility of registering a component globally or locally. I always recommend local registration unless you know for sure that a component will be used in multiple locations. In the end, it's completely up to you. It's all preference. In this lecture, we're going to discuss how to add styles to a component. There are a total of 3 blocks in a single file component. The template block is for your component's template code. You can insert expressions, directives, and use other components. The script block is for your component's options. This includes the data, methods, and business logic of your application. You will most likely use both blocks in almost every component. There is one additional block, which is the style block. Its purpose is simple. It's where we can define the styles for a component. We previously removed it. Let's add it back into the greeting component. From here, we can apply any stylings we like. Let's change the color of the paragraph to the color red. Next, let's try viewing the page again. Make sure your server is running by running the npm run dev command. After viewing the page, we will see the paragraph with the text color changed to red. This works, but it's not perfect just yet. We're going to inspect the element to view the paragraph styles. The color change is going to apply to all paragraph elements. It would be more ideal if the color change would apply to the paragraph elements in the component. The first solution would be to use IDs and classes. That would work, but Vue provides another solution you may want to consider. In the future, browsers will support something called the Shadow DOM. The Shadow DOM makes it possible to have multiple DOMs inside your document. The main benefit of the Shadow DOM is that it lives in its own little world. Any changes you make to that part of the page will only be reflected on that part. Vue is able to do something similar with its virtual DOM. You saw an example of this with the data property. Any data defined in a component is isolated to that component. Vue is able to isolate styles to a component. It borrows that idea from the Shadow DOM. The Shadow DOM is not to be confused with the virtual DOM. The virtual DOM is a JavaScript object that is a copy of the real DOM. The Shadow DOM is an isolated DOM from the real DOM. Let's learn how we can isolate styles to a component. First, let's create a paragraph tag outside of the greeting component. We'll add one inside the app component above the greeting component. It'll contain some static text. Next, switch back to the greeting component. We're going to add one simple attribute to the style block. The attribute we'll want to add is called scoped. By adding this attribute, Vue will compile the template while making sure the styles are only applicable to the component. To better understand what will happen, let's read the documentation. In the resource section of this lecture, I provide a link to the scoped CSS documentation page. Here is what Vue has to say about scoped CSS. When a style tag has the scoped attribute, its CSS will apply to elements of the current component only. This is similar to the style encapsulation found in Shadow DOM. It comes with some caveats, but it doesn't require any polyfills. Below are some examples. In the first code snippet, the scoped attribute is added to the style block. The second code snippet shows what the final result will be. Vue will add a data attribute to the elements from the component. The CSS selectors are modified to select an element based on the data attributes added to the elements. It's done for you automatically behind the scenes. This allows you to keep your code fairly minimal. We don't need to use ID or class names to achieve the same results. The styles we apply to a component will not affect elements outside of the component's template. Let's view the application one more time to see the result. There are two paragraph elements, one from the app component and another from the greeting component. We added a scoped style to the greeting component. It'll change the color of any paragraph elements to the color red. The paragraph inside the app component doesn't get changed to the color red. Only the paragraph tags inside the greeting component are changed. If we were to inspect the element, then we'll quickly find a data attribute has been added to the element as noted in the documentation. This was added in when the template file was compiled. One question I get asked is why does Vue choose to mimic the behavior of the Shadow DOM instead of actually using the Shadow DOM? The Shadow DOM is not completely supported in all browsers. Therefore, Vue will simulate the behavior of a Shadow DOM by adding additional details to your component. Despite the change, the concept is still similar. We can continue to make changes to the paragraph tag or any other elements inside the component. Those stylings will only be applied to the component itself. Sometimes you may want to check if the stylings are correctly loading in the document. If we were to go to the head section of the document, we'll find a style tag that's been dynamically added. Vue will generate a style tag with the CSS you've written for the component. That's the basics of adding styles to your components. We've learned how powerful scopes styles are. One of the major benefits of using scoped styles is that we didn't have to worry about dealing with classes or IDs. We didn't have to worry about stylings leaking into other areas of the page. This keeps our stylings clean and concise. We're using plain CSS at the moment. What if we wanted to use Sass? We'll look at how to use Sass in our application in the next lecture. In this lecture, we're going to learn how to use Sass in our project. The CSS we've written in our components is being processed as plain CSS. If you watched the previous section, you may be aware that I introduced Sass. The project we are currently working in does not have Sass installed, but it's easy to add if you prefer to use Sass. If you have the server running, then you will need to turn it off. Otherwise, we won't be able to install additional modules. Afterward, inside the command line, run the following command: npm install sass save dev. Next, open the greeting component inside your editor. We'll add an attribute called language to the style block. Its value will be SCSS. Our project is now using Sass. The great thing about using the preset that came with the Vue CLI is that it's configured to use most CSS preprocessors like Sass. Adding the language attribute will instruct the compiler to use the preprocessor for the language you're specifying. Let's give it a try. Update the selector with the hover pseudo-selector. Next, set the color property to the darken function with the following arguments: #cc4444 15%. Lastly, we'll turn on the server. We'll refresh the page one more time. Sure enough, the stylings still get applied. The Sass code gets compiled into CSS. It's a very simplistic approach to writing CSS. There's a lot more to using CSS in Vue, but we'll get to those subjects later. I encourage you to read the documentation to help you get a better understanding on how to use CSS in Vue. The more advanced topics are things we'll get to once we need them. We've learned how to create components and use them within one another. Any data you put inside a component will belong to that component. This means that you can have two components with the same property names without having to worry about naming collisions. This works for some scenarios, but there will be other scenarios where you'll want to communicate data between each component. Let's look at this diagram for a moment. We have three components. Component A is the parent component to component B and C. Component A is also known as the root component because it sits at the top of the hierarchy of components. Components B and C are not just children components to component A. They're considered sibling components to each other. This is because they sit on the same level in the hierarchy. Parents, children, and siblings are all terms you'll hear when discussing components in relation to each other. Let's take a look at how this will apply to what we're going to do. We're going to have three components for this example: the app, greeting, and user components. The user component currently doesn't exist in our project. We'll be adding it shortly. In this application, the user component will have a property called age. The greeting message will be based on the user's age. If their age is below 25, then we don't want to greet them. If they're above 25, then we will greet them. The question is, how do we send the age to the greeting component when it's stored inside the user component? The solution may be to send the data over to the sibling component, but that's currently not possible. Vue doesn't offer a way for components to send data to their siblings. If it isn't possible to send data to sibling components, then how do we share data? The real solution is to store the data inside the app component. We'll be able to send it down to the children components. Parent components are able to send data down to their children components. Therefore, it would make sense to store the data inside the parent component. From there, we can send data to components that need them. Data that is sent to components are called props. They're another way of adding data to your component. Let's learn how to use them in the next lecture. In this lecture, we're going to learn about how to use props in our components. You can think of props as custom attributes for our components. We can use props to customize the behavior of a component similar to how HTML attributes change the behavior of an element. Let's prepare our project. We'll start things off by creating the user component. Inside the components directory, create a file called user.vue. We'll add the template and script blocks. Next, export an object with the name property assigned to the value of user. We'll keep the template simple. It'll be a set of paragraph tags with the following text. The user is X years old. The user component is ready. The next step is to register it inside the app component. Inside the app component, we'll register the user component. The user component has been registered to the app component. We'll add the user component below the greeting component. Something I want to note is that the component can be written differently than how you define it inside the components object. Vue will use the name of the property as the name of the tag. You have the option of writing the tag name with lowercase letters even if the property name is using uppercase letters. In this example, we're using the lowercase version for the tag name. Vue allows you to write it either way, which can be nice since most element names are lowercase to begin with. We're going to change the greeting component to use the lowercase version. From here on out, we'll use the lowercase versions of components names inside the template block. One final adjustment. We're going to change this paragraph tag to an H3 tag. We're doing this so that it can stand out a little more when we're working on the application. Before we start adding data into the mix, let's confirm that the code is working. We'll refresh the page. Surely enough, everything is working properly. The user component is loading in just fine. we'll open the app component. We're going to add the data to the app component, not the user component. This way we can pass it down to both the greeting and user components. We'll add the data function using ES6 syntax. Inside this function, we'll return the object with the age property. We're giving the age property a value of 20. With the dataset, let's pass it onto the user component. Inside the template, we're going to add an attribute to the user component. In order to pass down data, we need to pass it in as an attribute. The attribute name can be whatever you want as long as it doesn't conflict with other attribute names. I recommend naming it something relevant. Since we're passing down the age, I think it would be appropriate to call it age. The value of this attribute is what will be passed onto the component. We want to pass down the age data property. You can hard code the value or you can make it dynamic. It's important to understand that the value will not automatically be interpreted as an expression. You have to bind it if you wish for it to be an expression. If we were to pass it like this, then Vue will assume you want to pass down a string. Therefore, we'll have to add a colon before the name to bind the attribute. Now Vue will send the age property inside the data object. We're not finished yet. The user component needs to accept the age. Switching to the user component, we're going to add a new property to the exported object called props. Props is short for properties. This will be set to an array. The array should contain a list of properties that the component will accept. We're going to accept the age. It's important that the name inside the props array matches the attribute name. This is how Vue connects the two. The age property is now available in our component. You can use it in expressions, directives, and methods. Inside the user components template, we'll replace the X in the static text with an expression that'll use the age. There's nothing more we need to do. Let's refresh the page. The user component displays the age dynamically. Even though there isn't a data property inside the user component, it's still able to use the age as if it were its own. The great thing about this is that the age will automatically be updated if the age in the parent component changes. Any changes are trickled down to children components. I can even prove this to you. Using the Vue dev tools, view the list of components available. The app component will have the age under the data category. If we were to view the user component, it'll have the age listed under the props category. Despite being in a different category, we can still use the age like any other data property. If I were to switch back to the app component, I'll be able to edit the age. If I increment or decrement the value, then you'll notice the age up top changes as well. If the data inside the parent component changes, then all children components will reflect that change too. Vue handles that process for you. However, it doesn't necessarily work in the reverse. If we were to attempt to edit the age inside the user component, then we'll quickly discover it's not possible. There are a couple of reasons for this which we'll explore in the next lecture. In the previous lecture, I showed you how to pass down data to a component. Once the data has been passed down, the child component can use the data in expressions, directives, and methods. However, there are some limitations you should be aware of, specifically on how you update the data. Before we review the limitations, let's pass the age onto the greeting component too. Inside the app component, we're going to pass on the age to the greeting component. It'll be the same as before. We'll bind an attribute called ageSet to the age data property. Inside the greeting component file, we'll add the props property and accept the age property. The next step is to use the age. Right after the first paragraph element, we'll add another one with the following message. You must be 25 years or older to view this message. For the first paragraph, we'll add the VIF directive. The condition will be age greater than 25. The second paragraph will have the v-else directive. The first paragraph will be rendered if the age property is greater than 25. By default, the age is set to 20. This will return false. As a result, the first paragraph will not be rendered. The second paragraph should render since it has the v-else directive. This is a very simple use case of conditional directives. This will always display the second message because we have no way to change the age in the application. Let's add a button that will do just that. Inside the app component, we'll add a button below the heading. We're going to listen for the click event and increment the age whenever the button is clicked. With those changes made, let's check out the application. Initially, we'll be greeted with the second message. If I were to click the button, then the first message will eventually appear. Both the greeting and user components are updated with the latest changes. This works fine. We don't need to make any adjustments to either component since the change is occurring in the parent component. However, you may want to change the data directly inside the child component. Let's try moving the button from the parent component to one of the children components. Back in the editor, we'll cut the button and place it directly inside the user component. This will result in an error because we are not allowed to mutate props. The reason we aren't allowed to do this is because the parent component will not be notified of the change. The changes will not be reflected in other components too. Another downside to updating a prop in a child component is not being able to hold on to those changes. If the parent component updates the age, those changes will override the changes in the child component. The parent component has priority over changes to its data. This means that the user component will use the age inside the app component instead of using its own version of the age. This is a problem as you may want to make changes to data inside children components, but have those changes reflected in all components. This includes sibling components like the greeting component. How do we let the greeting component know the age was updated? We'll discuss a solution in the next lecture. In this lecture, we're going to learn how to update props from the child component. Props are not allowed to be updated in child components. This introduces bugs and unexpected behavior in our application. But what if we need to update a prop from a child component? We're going to be doing something called emitting events. The word emit means to produce or trigger something. When you click on a button or element, JavaScript will emit a click event. It doesn't call any specific functions. Instead, any code that listens for that event will run. We're not limited to the standard JavaScript events. We're allowed to emit custom events. Vue makes this process easy by providing a function that does just that. After emitting a custom event, we can listen for those events in our application. We already know how to listen for events. All we need to learn is how to emit them. It's quite simple. Inside the user component, we're going to change the expression inside the click event. Rather than incrementing the age, we're going to call the function onClickAge. Next, create the methods object and define the onClickAge function. We'll be using the shorthand ES6 syntax version for defining the function. The next step is to emit an event. Vue has a special function for doing this. We can emit an event by calling the this.$emit function. This function will emit an event that other components can listen for. Something I want to point out that I mentioned before is the function starts with a $. Vue likes to name its own functions and properties with a $. This makes it easy to tell the difference between an official Vue function and some function by other components or libraries. It's a simple way to differentiate between things. Alright, moving forward, this function requires one argument. It requires the name of the custom event. You can call this whatever you want, but I always recommend keeping it simple and concise. We'll set this to age change. We're almost finished. Any parent components can listen for the event. The next step is to have the parent component listen for this event. We're going to listen for the event inside the app component. This is because only parent components can listen for events from children components. This event is inaccessible to the greeting component. That's fine, as the app component is a parent component to the greeting component. If we change the age inside the app component, then all children components will update as well. To listen for an emitted event, we can use the vOn directive. We'll apply this to the user component, but with the shorthand syntax. The name of the event is the name we used in the first argument of the emit function. In this instance, this would be age change. Listening for a custom event is the same as listening for any standard JavaScript event. From here we can run an expression. We'll increment the age. This is what will happen. When the user clicks on the button inside the user component, this will run the function onClickAge. The onClickAge function does one single thing. It will emit an event called ageChange. Any components that are using the user component will be able to listen for any custom events emitted from it. That's exactly what we do in the app component. To listen for an event, you use the vOn directive or the shorthand version @. You listen for the event like any other event. If the event is triggered or emitted, then the expression inside it will run. In this example, the age is incremented. Let's test if this is true. Try clicking on the button in the browser. Initially, the age will be 20. The age will increment by 1 on each click. If it surpasses 25, then the greeting component will update with the appropriate message. This is exactly what we wanted. We're no longer updating the age inside the user component. We're simply emitting an event. The app component is what changes the age. Since the age gets changed inside the app component, then all children components get updated with the age as well. Admittedly, it's quite a few steps to do, but you'll get used to it the more you practice it. Let's take it a step further. In some cases, we may want to pass data from the event to any listeners. For example, let's say we wanted to pass on the value that should be added onto the age. Inside the user component, we can pass an additional argument to the $emit function. The additional arguments will be passed onto any listeners. We'll pass in the number 3. This is what will be passed onto any listeners. To use this value, we'll need to update the code inside the app component. Instead of incrementing the value, we'll call a function. The name of the function will be updateAge. Next, we'll add the methods property to the object below. We'll define the updateAge function. We'll accept the number passed in as num. Lastly, we'll add the number to the age. Refresh the page and try testing out the button. Instead of incrementing the value by 1, it will increment by 3. Passing in values is very simple. There are 2 steps to the process. First, you pass the data as you're emitting the event. Second, you can update your expressions to run functions that accept in the data. In the console, we'll receive a warning by Vue. It's telling us that we should add the emits option to the user component. This is because Vue wants to know what events the parent component can expect from the child component. Back in the editor, we'll update the user component. We'll add the emits option. This will be an array of events that will be emitted from the component. We'll add the age change event to the array as a string. The reason Vue recommends adding emits option is because it helps document what the component does. It's a recommended good practice. One last thing I want you to be aware of. This process is only necessary when we need to make changes to any of the props. We can continue to use props inside computed properties or methods. It's perfectly fine to use props as read-only values. Let me show you an example. Inside the user component, we want to display the age doubled. Switching to the user component, we'll create a computed property called age doubled. Inside the function, we'll return the age property multiplied by 2. Every prop is accessible directly via the this keyword. Vue will take care of proxying the value. In this example, we're not directly changing the prop. Instead, we're grabbing the value and using it to create a whole new other value. We'll create an expression inside the template to output the age doubled computed property. Refresh the page after making those changes. The age has been doubled. This is because we're not directly changing the value. If I press the button, then the age gets incremented like before, but the user component is still doubling the value. With every change, we still don't get any errors. Once again, this is because we're just grabbing the value. We're not changing it. If you plan on using the value, but not changing it, then it's not necessary to use events. That's very important to know, as you don't want to end up writing too much code. We've learned how to add props to our components. They're data passed down from a parent component to a children component. We can take it a step further by validating the values. Validating a prop can be useful for debugging your application. If you have a component that's used in dozens of locations, then you may want to make sure that a prop is a specific data type. By adding validation, you can catch if a component is passing in the wrong type of data, allowing you to fix it before shipping your app to production. Validating props is very easy. Inside the user component, we're passed down a prop called age. The age should always be a numeric value. Let's validate it. Rather than passing in an array, we can pass in an object of props to accept. Each property in the props object will represent a prop. The key name is the name of the prop. We have one prop called age. The value of this should be an object. The object will contain the validation rules, if any. The first rule you can set is the type. The type is the data type the prop should be. All JavaScript types are supported, such as string, number, object, array, etc. In the resource section of this lecture, I provide a link to the types you can use. There are additional types like date and symbol available. If we scroll up above, we'll find examples on how to validate props. Feel free to read over this once you're finished with this lecture. Let's switch back to the component. We'll set the type to number since we want numeric values. We're not limited to one data type. You may want to allow multiple data types. If this is the case, you can replace this with an array and then add the data types you'd like to accept. I can add in number and string. I'm going to revert this back since I want to restrict this to numeric values. I just wanted you to be aware that it is possible to check for multiple data types. We're not limited to checking the data type. We can make the prop be a required value. In the object, we'll add a property called required. Its value will be set to true. Anytime a component uses the user component, they're required to pass down an age. If they don't, then it'll throw an error. Let's test out both rules. Switch to the app component file. Let's remove the age prop from the user component in the template block. Next, let's refresh the page. Upon refreshing the page, we will get an error inside the console. It's telling us that the user component is missing the age prop. It's also telling us that this error can be found inside the app component file. Pretty useful information for debugging the application. Let's add the age back in. After making that change, the error inside the console will disappear. Now let's try testing if the type rule works. We're going to open the Vue Dev Tools. The age can be found inside the app component. We're going to change the value to a random string. After changing the value, an error will appear in the console. It says the following: invalid prop. Type check failed for prop age. Expected number got string. This shows that the type rule works. Once again, I want to stress that this is really useful for debugging purposes. If you're using a prop that is generated by user input, then there's not much you can do to prevent them from passing in an invalid type. Even with form validation, there's still a possibility for this error to appear. Just be aware of that when using props. There's more we can do with validation. We can set a default value. Back inside the user component, we'll add a new property called default and set it to 20. Since there's a default value, we don't need to have the required property. We'll comment it out. With the default key set, we're always assured that the prop will have a value even if one is not passed down. Something I want to note is that the default key must be set to a function if the type key is set to be an object or array. The function must then return the object or array. This is one of those weird quirks of using the default key. So far we've covered the three main ways to validate the prop. Sometimes this may not be enough. You may want to have custom validation. That's possible with the validator property. We'll comment out the default key. Then we'll add in the validator key. The validator key must be set to a function. The function is passed in the value of the prop. We'll be able to perform validation on the prop value. The function expects you to return either true or false. If true, then the validation passes. If false, then the validation fails. Inside this function, we're going to return the following: value less than 130. The condition will check if the value of the prop is less than 130. If it is, then the condition will pass and the value returned will be true. Therefore, the validation will pass and the application can proceed like normal. The reason I'm checking if the age is lower than 130 is because there isn't anyone who is over that age. It wouldn't make sense for anyone to be older than 130. We'll refresh the page to test this out. We'll continuously click the button until the age exceeds 130. Surely enough, we get an error in the console saying invalid prop. Custom validator check failed for prop age. Fantastic! As you can see, Vue provides a lot of flexibility for validating your props. You could probably add a mechanism for preventing the age from exceeding the maximum age to prevent this error from being triggered. Try doing that on your own as a fun side challenge. One last important note I want to add in before I end this lecture is that the validator functions run before the instance of the component is created. Therefore, you won't have access to the data, computed, or methods properties inside the function. For example, back in the editor, we'll try calling the onClickAge method inside the validator function. Switching back to the page will tell me that the method is undefined. This is important to know, as you may try to access other parts of your components and run into errors after doing so. It's because the Vue instance hasn't been created. Therefore, you won't have access to any proxy methods or properties. I'll comment out the line before proceeding to the next lecture. Emitting events has proven to be the best way to update data in a parent component from a child component. There are libraries out there that make sharing data between components easier. We'll get into those later in this course. In this lecture, I want to introduce an alternative solution for updating data in the parent component from the child component. Callback functions can be used to update data. If you are familiar with React, then you will feel right at home with this method of sharing data. Creating callback functions is a very simple process. Let's explore how to create one. Inside the app component, let's create another method called updateAgeCB. It will do the exact same thing as the updateAge function. I'm creating two versions of the same function so that we can compare the difference. We're going to pass this function down to the user component. You heard that correctly. You're not limited to sending down primitive values. You can also send down functions, objects, and arrays. We can pass this function to the user component just like we would for any other prop. Inside the template, we'll bind an attribute to the user component called AgeChangeFN with the value of UpdateAgeCB. The letters FN are short for function. Let's switch over to the user component to accept this function as a prop. We're going to set this to function. We're not setting this to an object like we did with the age. If you are only planning to check for the type, then you don't need to set this as an object. Instead, you can directly set the type. That'll work fine. With the function added, we can use it in our code. Inside the template, we're going to make a copy of the button. However, this time we're going to directly call the callback function. We'll pass in the number 3. We're going to update the text inside both buttons. We want to be able to tell the difference between the two. Let's refresh the page to see what happens. If I were to click on the second button, then we will see the age increment by 3. The app component will continue to update the age. Both children components are provided with the changes. When we use the callback, we're basically passing in the function to the child component. However, when we call the function inside the child component, it's not like the child component has a copy of the function. Instead, it's calling the function inside the parent component. The function inside the parent component will have access to the data. Therefore, that is where the data will change. At this point, you may be wondering, which is better? Should you use callback functions or emit events? It really comes down to preference. As far as performance goes, both methods of communicating data are about the same. You won't see any significant performance gains from using either one. According to Vue, it's recommended to use events. Most examples you'll find in the documentation use events. For consistency reasons, I recommend using events. There is one advantage to using emitted events. I'm going to refresh the page. Then, inside the Vue Dev Tools, I'll switch to the Timeline tool. The Timeline tool will display a list of events emitted by our app. It'll even display events emitted by the browser. There are 3 categories of events. I'm going to click on the button that emits an event. After clicking this button, an event has been logged. We can click on this event and view the details of what the event was. We're given the name of the event. We're also provided the source. It tells us that the event was emitted from the user component. Lastly, we're given the payload. The payload is the data that was sent with the event. All of this information is useful for debugging the application. If I were to click on the callback button, then nothing will get logged, not even in the console. This makes things a bit harder to debug. Of course, you could log this manually, but that can cause more headaches than it can solve. If you were to change any names, then you would have to change the log information. With events, the names are already logged for you, so there's no need to do it yourself. This is one of the main reasons you would want to use events. On top of that, most tutorials and documentation use events for communicating data between components. Therefore, you'll see a lot of applications using that practice. At the end of the day, it's up to you. You can use callback functions or emit events. In this lecture, we're going to learn how to use slots in our component files. Slots are a great way to pass down content from a parent component to a child component. They are an alternative to using props. Slots are very popular among library developers. It would be beneficial to understand how they're used. They can be really useful when you need to make your code more reusable. What do I mean by that? Well, let's look at a real use case example. We'll be working on a new project for this example. In the command line, run the following command: npm init vue at latest. During the setup process, set the name of the project to slots. Next, select no as the response to all questions. We're going to be working with the bare minimum. Lastly, we'll move into the new directory. The packages must be installed. Run the npm install command. Next, let's start the server with the npm run dev command. Let's do some cleanup. In the Components directory, delete all component files. We won't need them for this demonstration. Up next, we'll update the app component. We're going to remove the style block from the component. Then, we'll strip the template and script blocks to the bare minimum. From the script block, export an object under the default namespace. Set the name property to app. We're ready. Let's start working with slots. Inside the template, we're going to create a simple form. The form will have 3 intersections. We'll use div tags to create these sections. The sections will be called Help, Fields, and Buttons. The Help section will contain some help text to inform the user on how to fill out the form. The Fields section will hold the input fields. Lastly, the Buttons section will hold the submission buttons. We're going to fill out each of these sections quickly. This is how forms are typically built. You split everything into sections to keep your markup structured. It's a common methodology of approaching forms. I'm not using any expressions or directives inside the form. It's just plain HTML. You can think of this as a login form. We can improve the form by putting it into its own component. It's getting rather large, so placing the logic in a separate component would be a good idea. Let's do that. Inside the Components directory, create a file called form.vue. We'll add the template block to the file. We're not going to bother with the script block at the moment. The goal is to move the form into a separate component. We'll cut the form element from the app component. Then, we'll paste it into the template block of the form component. We'll want to register the component locally. Switching back to the app component, we'll import the form component. Next, we'll register the component by adding the components object to the exported object. We're prefixing the name with the word app. That's because there's already an element called form. We don't want to have a naming conflict. This is another reason why it's always considered good practice to namespace your component names. Back in the app component file, we'll add the form component where the form was originally located. I'm lowercasing the words and adding a dash between them. This is an alternative way to write components. In an earlier lecture, I talked about how you can use kebab case or Pascal case for your component names. If you opt into using Pascal case, Vue will allow you to write the component with lowercase letters. It'll add a dash before each letter that was capitalized with the exception of the first one. We can use the original name, but I like to use the lowercase version because it keeps things consistent inside the HTML. Native HTML elements are always lowercase. Alright, let's move on over to the browser. Surely enough, the form gets rendered. There's nothing wrong with the form, but there are some limitations with the component. A form is a common UI element in any application. It's likely that you'll have multiple forms. Some examples would be a login form, register form, contact form, etc. They may have different input fields and objectives. However, they may look visually consistent. This means you're probably using the same markup structure and classes. It isn't just forms that suffer from this problem. Most UI elements are reusable. If we were to go back to the application, we wouldn't be able to reuse the component. Instead, we would have to create another component if we wanted to reuse the form. Let's say we wanted to create a contact form. The contact form would use the same base HTML, but with different input fields. I want to be able to reuse the form component. We could do this a number of ways. For example, we could use props and pass down the stylings and fields. That's a viable solution, but passing down HTML through props isn't really fun. This is especially true if you have complex markup. The recommended solution is to use slots. We'll create the second form in a moment, But first, let's explore how to create a slot. Before using slots, you need to identify which parts of your component are reusable or unique. Inside the form component, the markup that will be unique are the 3 sections inside the form. I'm going to cut all 3 sections. Then I'll transfer them over back to the app component. We're going to paste the markup inside the app form component like so. Vue allows us to pass down markup in between the components tags like we're doing here. However, this won't work just yet. We have to instruct Vue where to render the markup in the child component that's receiving the markup. Switching to the form component, we're going to insert a tag called slot. We'll insert it inside the form element. The slot tag we're using is a component created by Vue. It'll get replaced by the content that gets passed from the parent component. Let's move over to the browser to view the result. The form renders normally. Slots are a way to pass down markup from the parent component to the child component. In this instance, we're passing down these sections to the form. The slot tag we have inside the form component will be replaced with the content passed in. There may be some scenarios where no content will be passed in. We have the option of rendering default content. Back in the editor, in between the slot tags, we can add some default content. We'll add the following: no form to render. If content is not passed down from the parent component, Vue will use the content inside the slot component. We can test that out by switching over to the app component and using the form component twice. For the second copy, we'll leave it empty. Hopping on over to the browser, we will see the first form rendering. The second form will have the message inside the slot rendering. Having default content is optional and can be useful just in case you forget something. This is the basics of creating slots. We'll stop here. In the next one, we'll look at how we can further improve this solution. In this lecture, we're going to explore how to create named slots to optimize our component. First, let's update the second form with some inputs. We'll turn it into a contact form. Inside the app component, we'll copy the content passed into the first form. We'll paste it in as the content for the second form. Next, for the second form, we'll change the help desk and the input fields. We have 2 forms using the same component, but with different inner content. Let's test if this works. Inside the browser, the 2 forms will render without a problem. The main benefit of using slots is the ability to create one component that will act as a skeleton. The form component is some base markup with a slot for the parent component to insert content into. By having a skeleton, we only need to create one component. We didn't have to create 2 separate components like a login component and contact component. We have a generic form component instead. In a sense, this makes the component more reusable. This is what slots are mainly used for. To be truthful, this component isn't the best example. In a real-world example, your skeleton would most likely have much more markup than just a form element. It would be beneficial if we could distribute the content better. That's possible with something called named slots. For instance, inside the app component, the markup between both forms have the same 3 sections. It would be better if we could leave these sections inside the form component. We'll switch back over to the form component and add in these 3 sections again. They were the help, fields, and buttons sections. Inside the help section, we'll insert the slot component again. This time, we'll add an attribute called name. We can assign slots unique names by adding the name attribute. We'll give this slot the name of help. By assigning a name, we're given more control over where the slot content is distributed and placed. This also allows you to have multiple slot locations. We'll add slots to each section with the name attribute. We can call our slots whatever we want. I recommend giving them something relevant. There will be a slot for the Help, Fields, and Buttons sections. We can go back to the app component to use these sections. Instead of using the class attribute, let's change each of these to the vSlot directive. The vSlot directive can be used to tell the child component where the slot content should be placed. We need to add a colon after this directive followed by the name. The name corresponds to the value we used for the name attribute in the child component. We'll assign this part of the content to the Help section. The second div element will be for the Fields section. Lastly, the third div element will be for the Buttons section. We'll do the same for the second form. By using the vSlot directive, Vue will be able to identify where to load the content in the child component. There's one problem with this. The vSlot directive may only be applied to template tags. This is a limitation you should be aware of. We can't use this directive on the div element. The solution is simple. We'll replace the div tags with template tags. Let's check if everything worked. Switch over to the browser to check the application. Both forms are functioning correctly. Thanks to named slots, we have more control over how content is distributed from within the component. We aren't limited to using named slots. We can use a combination of named slots and default slots. Let's go back to the editor. Inside the form component, we'll add a slot at the bottom of the form. By having a slot with no name, any elements that aren't assigned to a specific slot will be put there by default. Back inside the app component, we'll add a paragraph tag at the bottom of the first form with some dummy text. If everything I said was true, then the paragraph tag should be placed at the default slot location. Upon refreshing the page, we'll find the paragraph element added to at the default slot location. We can use a combination of named slots and a default slot. It's up to you. We can take this a step further. One advantage of slots is the ability to use data from the parent component. Let's try that out. Inside the app component, we're going to create the data function. We'll create one property called help that will contain the help text from the first form. We can use this data property inside the content itself. We don't have to use a prop to pass it on. Inside the first form, we'll replace the help text with the expression help. This will work because technically we're still inside the app component. Since that's the case, then we still have access to the data, computed properties, and methods inside this component. Therefore, there's no need to pass this down as a prop. Hopping back to the browser will show that the expression works as expected. If you don't plan on using the data inside the child component for functions or computed properties, then there's no need to use a prop. This is a perfectly fine alternative. As you can see, slots can provide for a more interesting way of structuring your application. In the resource section of this lecture, I provide a link to learn more about slots in Vue. I recommend giving it a good read if you want to know what else you can do with slots. The last thing I want to go over in this section are dynamic components. A dynamic component is a component that can be swapped with other components. This allows you to toggle between components. Using dynamic components isn't difficult, but there are a couple things you should be aware of when using them. I'll discuss everything you'll need to know in this lecture. We're going to work in a new project. Using the command line, run the following command: npm init vue at latest. Set the project name to Dynamic Components. Select No for all questions. Lastly, let's move into the newly created project. Inside the new project, install the packages with the npm install command. After moving into the new project, be sure to turn on the server with the npm run dev command. Since this is a new project, we'll need to clean things up a bit. Inside the components directory, delete any components created by the CLI. Open the app component file next. We'll want to remove a lot of the content. We'll delete the style block. The template and script block will be emptied out. Lastly, export an object with a property called name with a value of app. We're starting fresh to focus on the idea of dynamic components. We'll need to create some new components for showing how dynamic components work. You'll see what I mean in a moment. We'll create two components called About and Home inside the Components directory. For the About component, we'll add the template block. Inside of the block, we'll output a message. We'll do the same with the Home component. We have two distinct components. I want to display the component depending on a user selection. We'll create a drop-down where the user will be able to select what component they'd like to view. Switching back to the app component, we'll create a drop-down menu. We'll add two options which will be Home and About. We'll use the drop-down to select the component we currently want active. First, we'll need to import the components. We won't be able to use them if they're not imported. Inside the script block, import both the Home and About components. Next, register them by adding the Components option to the configuration object. After registering the components, they're available to use in our template. However, we don't want to load the components. We want to load them depending on the value inside the drop-down menu. We'll need to store the selection in the drop-down menu to keep track of what component to load. We're going to define the data function inside the exported object. Inside the data function, create a property called component name with a default value of Home. There's nothing else we need to keep track of. The component name is all we need. You'll see why in just a moment. We're going to update the drop-down next. It's what will allow the user to toggle between components. Inside the Select Form field, we'll add the vModel directive. The expression will be the component name data property. We have the drop-down working and we have the components registered. The last thing we need to do is actually load the components dynamically. Vue provides a component called Component. We'll add that right below the drop-down. The Component component allows you to dynamically load in a component dynamically. You can think of it as a placeholder for the actual component. To set the component to load, we need to add the attribute is. We'll bind it. The value for the is attribute must be the name of the component that's registered globally or locally. If we want to be able to toggle the component, then we'll need to bind this attribute. If you don't bind it, then the component will always load the same component passed in. The value for this should be component name, which holds the value inside the dropdown. That should do it. Let's test the application by opening it in the browser. The app is running normally. The drop-down should have the Home option selected by default. The Home component is rendering because it's the default value for the drop-down. If we were to toggle the value to About, the About component will appear. We can continuously toggle between the two components without a problem. This is how we can create dynamic components. We can use the component inside our template. Then we can pass in the component name into the is attribute. We can create some interesting interactions with this component. For example, a tabbed component or menu navigation. There is something you should be aware of though. When a component is toggled out, it gets unmounted. This means that any data inside of it will not be available anymore. If the component gets reintroduced on the page, the data will be reset to its default state. We can even view the component getting unmounted by using the lifecycle hooks. Let's use the lifecycle hook to confirm that. Back in the editor, inside the home component, we're going to add the lifecycle function. Inside of it, we will log a message indicating that the component was unmounted. After making those changes, let's refresh the page. If we were to toggle the components, the message should appear in the log. This will inform us that the home component was unmounted. Every time I toggle the home component, this message will appear. This is important to understand, as any data you have in a component will also be destroyed. Any events you may have attached to that component will become unavailable. The default behavior can work fine. Other times, you may want a component to persist. Vue provides the option of allowing persisted data. Back inside the app component, we're going to wrap the component with a component called keepAlive. This component does one simple thing. It keeps the component that's inside of it alive. Even if it shouldn't appear in the DOM, this will make sure the component lives in memory. If the component needs to be added onto the page again, Vue will use the one in memory rather than creating a new component. Back on the page, we can toggle the selections like last time. Everything works, but behind the scenes things are different. We won't see the message being logged inside the console because the component is not being destroyed anymore. Instead, it's being kept alive in memory, therefore the unmounted lifecycle hook is no longer triggered. Switching over to the Vue developer tools, we can see that both components are still inside the app component. Instead of completely removing one, Vue will set the component as inactive. This will mean that the data will still persist, but it won't appear on the page. This can be useful for when you don't want to make an additional request for the same data. Of course, this does have one disadvantage. Since the unmounted lifecycle function doesn't get executed anymore, then you won't be able to run code if the user switches off the component. You may want to run code when this occurs. Luckily, Vue compensates for this by introducing 2 additional lifecycle hooks that weren't available before. Inside the home component, we'll add the 2 lifecycle functions called activated and deactivated. Inside both functions, we're logging a message. The activated function is called when the component is active. With both functions set up, let's refresh the page. As I toggle the components, the activated and deactivated lifecycle functions are called, thus giving you the opportunity to execute code when the components are toggled. That's about it when it comes to using dynamic components. I'm sure you'll find a lot of uses for this in your applications.